so it hit the normal, and then it get refracted and get the degree. The degree would change, so that's what we call refraction. So we have here the law of refraction, or we call it Snell's law. So what is this? Is the incident ray, the infracted ray, and the normal are in the same plane? So the incident and then refracted ray and the normal are in the same plane. Okay, the ratio of the sine of the angle of refraction to the sine of the angle of the incident equals to, so sine of the alpha 2 1 is equal to the speed of propagation in the new medium to the divided by the speed of propagation to the first medium, to the old one. Okay, so this is an important formula. Let's go to the refractive index. Refractive. And let me know in the comment that if there is any problem with my handwriting, I can just write better. Okay, refractive index of a medium. The ratio of the speed of the propagation, so is n. Speed of propagation of the wave in the reference medium, for example a vacuum in the case of light, to the speed propagation of the wave in a given medium, so C or V. So C is the reference medium, like in the case of light, or like whatever is the reference, which most of the cases are light. And this is the speed, so the given medium. Okay. The media with a higher optical density that is in which light propagates slower. So in the higher optical density, the light propagates slower. Of course, because the density is higher, so the propagation of the light would be less. Have greater refractive index. Greater refractive index. Greater refractive index. Okay. If we want to use the refractive index in the Snell's law, we're gonna get this formula. And 1 sinus alpha, like the 1 equals n2 sinus theta 2. Okay. Just for an example, just to know for some substances what are the refractive indexes. Just for example, we have to say air, which is 1, glass, is 1.5 till 1.6. Diamond is 2.419. And then like the most is the diamond. Of course, because diamond is the strongest thing in the planet. Then we move on to dispersion. So what is dispersion? Dispersion is a refractive index n of a medium as a function of the wavelength. So it will be different. It will be different for waves with different wavelengths. Different for waves with different wavelengths. Okay. So, what is a dispersion exactly? You can see this picture is a prism. In this prism, you can see that there is a white light coming toward the prism, and then it changed to also a rainbow. So what we can call it? So a white light is a mixture of main colors. It can be broken down into these colors by a dispersive element, which is the prism, the dispersive element. And we have another thing as well, which we call it grating. These two are the dispersive elements. As I told you, here is like a rainbow, right? Actually, rainbow is a raindrops with refract different colors of light at different angles, right? So white light is broken down in different colors. So the raindrops will refract different colors. That's quite interesting. Okay. And then we have monochromic rays. What are those? Sorry. So monochromic rays are rays that be described by a single wavelength, as you can see in the mono, which means one, so can be described by a single wavelength. Okay. Then monochromatic rays. Sorry, here is monochromatic. Sorry. Monochromatic rays cannot be broken down into future components by a dispersive element. They follow a single path. So they follow a single path. So the dispersive elements couldn't do anything with them. Okay. And actually, the prism, I think you would see it was in one of the Pink Floyd's album cover, which I thought is interesting to share with you. Okay, then we're going to total internal reflection. Okay. Let us assume a light travels from a medium of refractive index n1 into an optically less dense medium with refractive index, which we can say n1 is and is less than 1. If you want like a glass to air, this is less than for sure. This is more. Okay. In this case, the angle of refraction will be greater than the angle of incidence. So, angle of refraction be greater of angle of the incident. We have something, we call it critical angle. What is critical angle? Let me show it like this. An angle of incidence at which the angle of refraction is 90. So the refracted ray would move parallel to the boundary between the media. So if we write it like this, is equal to n2 sinus 90 degree equal to n2. From here we can get this formula, which is n2 divided by n1. Okay. What happens though when the angle of incidence is greater than the critical angle? There will be no refracted ray. The incident ray will be fully reflected. The incident ray would be fully refracted. Okay. Then we have total, what we call a total internal reflection. Total internal reflection. What is this? When light is directed from a medium towards a medium with a lower refractive index, rays above the critical angle will not be refracted but will be fully reflected. So it would be fully reflected, but not refracted. And then, when light is directed from a medium towards a medium with lower refractive index. Okay. Then we go into optical fibers. What are the optical fibers? As you know, I think you heard it a lot of places, for example in the Wi-Fi cables. This is an optical fiber. They have an incident ray, and as they have a strong layer. So the strong layer would reflect the ray, so it can go on and on till the end of the optical fiber. And no light can leave it. Please subscribe and like if you enjoy it, and hit the notification bell so you're always alerted when I upload a new video. Hope you have a great day.